My name is Hallie Rocco, and today I will be talking about a chronological analysis of developments in chemical engineering. So this is my overview slide. We're going to start by discussing the methodology. We're going to use early forms of chemical engineering, formation of chemical engineering, the four major stages of chemical engineering, which would be the paradigms discussed in the later slides, and then we'll go to the conclusion slide. So first, the methodology I used to prepare this presentation was I cross-referenced various academic papers, and I took different facts from them and I put it all into one sheet, and I just established what I wanted and where on the slides. I used research through historical websites, and I observed process statistics as well, because the academic papers had a lot of different statistics and calculations throughout them. Early forms of chemical engineering. So fermentation and evaporation happened in ancient civilizations, and then we moved on to another form of applied chemistry, which was using the chemistry to make certain products that the society needed. So this would include the salts, the soaps, they made glass, they made sugar and sulfuric acid. And then my example was that the Roman Empire actually perfected glass making, and they use the same materials and the same methods today that the Romans did thousands of years ago. And this is a picture of a glass pot that is from an ancient civilization. So the background for the official formation of chemical engineering, it was the end of the 19th century, and there was competition between the great powers of the world, so European countries and the United States. So this came from a high demand for people with expertise in chemical engineering that could help improve the markets and make the products that everyone wanted. So they used different professors from different universities that specialized already in chemistry, and they started to dig more into the engineering aspect of the chemistry. So in 1885, Professor Armstrong taught the very first chemical engineering class, and this was actually in England. So it wasn't the United States. And then the first chemical engineering textbook was published in 1901 by George E. Davis. And this is when we first got the inside look of unit operations. And in 1888, MIT was the first university to offer a 4-year complete curriculum and degree in just chemical engineering. And then chemical engineering really took, its popularity really came from the need for petroleum industry to be formed and standardized. And this is a definition of a paradigm. So a paradigm is a universally recognized scientific achievement that honestly provides a model and a basis for further exploration in that topic. And this is a definition taken from the American Heritage Dictionary. So the four paradigms, and these are proposed paradigms, so they're not official, but based on the research that I found, these are the most discussed paradigms. And number one would be unit operations, then transport phenomena, then chemical product engineering, and then sustainable engineering. And this is a flow chart that describes each of them, and it breaks it down into what those paradigms are really about. So unit operations actually emerged in the second half of the 19th century, and it really was coined by George E. Davis, as I stated in a previous slide. And it took large-scale chemical manufacturing operations so that they could just continue pumping out huge amounts of products, instead of it just being a specialized technical kind of category. They introduced a systemization of knowledge, so then everyone could use this textbook at every single plant so that we know products are being made safely and in appropriate ways. And it was based on fluid flow and mass transfer. Transport phenomena is all about momentum, energy, and mass transfer. So you took the differential equations and you took boundary conditions for different systems, and they applied it to the chemical industry and the formation of products. So unit operations is a direct application of these three phenomena. Increasing scientific knowledge of processes, so they went more in depth and they categorized everything further and further and made it more systemized. So every single detail at that point was recorded. Chemical product engineering. So the second part of the 20th century is when this more so came into play. And it was a competitive market environment where everyone was making products. They all kind of had like the same exact quality. They didn't have anything varying from each other. So at the end of the day, it was just, okay, what name's more popular or which one's cheaper? So there was a higher importance established of product quality. So now instead of everyone producing the same thing, the same process and the same chemicals, everyone started trying to specialize their own in a different way. And how much now was produced is more important, like how much was sold was more important than how much was produced. Where in the past they just produced as much as they could and didn't really matter how much was sold. It also established the importance of, now we're not just like, as chemical engineers, we're not just caring about the economic standpoint of what's cheaper and what's easier. Now we're caring more about the quality for the customer. And then sustainable engineering is chemical industry is a huge materials and energy consumer. So they recognize finally that all of these processes that we're using take a huge amount of resources. And these resources may or may not be the best to take from the earth because they cannot renew themselves the way that they should. So they acknowledge the limitation of these resources, and they finally did more research, and they tried to apply techniques that allowed for us to not continue using harmful products for the environment. And they had alternate sources, and these are now being said, chemical engineers are now being said to be attacking problems like the freshwater shortage instead of just how can I get more Gatorade products to be produced in X amount of time. This is my conclusion. So chemical engineering has been around for thousands of years. It officially formed in the late 19th century. It has 4 proposed paradigms that we discussed in the earlier slides. And these are my sources. Are there any questions?